velocity, right? So that's step one, is momentum's always conserved in every collision. So we can do that. Times 351, 4.212, and then I'm going to divide by this, divided by parenthesis 3.215 plus 0.012. And I get that this velocity is 1.305237, dot, 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 yeah? And then I can say, I can use energy, right? And I can say that the kinetic energy here is equal to the potential here. Yeah? Can't I cancel out the mass? Yeah, I believe I can, right? Okay. And then I know the velocity. So isn't h, can't I just divide this by g? G is 9.8, by the way. Yeah? So h is going to be 1/2 times 1.305237, right, squared, divided by 9.81. So let's square the number on my calculator and multiply by 0.5, divide by, and I get that h is 0.86831 meters, 8.7 centimeters. Sometimes kids start pounding on the wall, I pound back. That's not so bad. Is that bad? Yeah. Right? Now, how do you, this is obviously not what they did. They didn't calculate how high it was going to go. They used how high it was going to figure out the velocity of the bullet. Yes? Yeah, so let's do one of those, huh? Oh, look at that. Hey, we got the right answer. Okay, so let's suppose that the block, we have a different bullet mass, right? So 0.0065 kilograms, 6.5 gram bullet, right? And then it's 0.042 meters, right? So how do we do this backwards? Well, step one, use this equation. Use 1/2 mv squared equals mgh, right? Use this guy to find the velocity, right? Then use mv equals mv, right, to find that velocity. Yeah? I think it's more fun if you do it, don't you think? Yeah. Bust out a calculator. Taran was working on stuff. Potatoes. Yeah. Uh-huh. Let me erase the old problems because it's confusing me. Okay. Bless you. Look at the poor guy. The stress of... You got the answer? You were singing? Okay. We should bust that out here. Yeah. Yeah, yeah.
Right now.
So the first step, if you set kinetic equal to potential, right, this is what I'm getting for the velocity, so check that. I'm getting that this velocity right here is 0.907766, etc.
That's what I got.
Do we have that? And then the next step is to set up momentum, right? So that's the bullet and the block going that fast. How fast does the bullet have to go to have the same momentum? Is the question. I can tell Jasmine's done. She's got her head down. Solving, solving, solving. He's getting the rest that he needs for the big game tonight.
4.5 meters a second. No. Totally wrong.
No, it's not totally wrong. He's off by a factor of 100. So how can we help him out here?
Move your decimal place over 2.
Yeah.
450 meters a second.
Exactly.
He's got it.
He's got it. If today was divide by 100 day, you'd be just spot on. Why I'm not a very nice teacher. If it was divide by 100 day, that'd be pretty good there, Kate. Harry Potter. My shirt is untucked. You don't like Harry Potter?
Not so much. Probably.
Do you like Twilight more? I guess I'm sort of put off in Twilight. Why does Stephanie spell her name Pheneie? Stephanie? I don't know. That's like the one in Shannon, you know? I don't know. How are we doing? Are people, do you need more time, or are we lost, or? So this is how you would determine the speed of the bullet. Yeah? Hey, we got the same answer. Okay, so